Hey, this is Sleeper. Welcome back to my channel. We're continuing the Bug Bounty Hunter job role path with the JavaScript Deobfuscation module. If you need access to Hack the Box Academy, I definitely recommend this silver annual plan as it gives you access to all the job role paths, all the modules up to Tier 2, and an exam voucher, which includes 2 exam attempts. So check that out. You can use the link below. Let's go ahead and get started. I'm going to skip this time because, as I learned last time, it kind of introduces it in the introduction. So here we go. JavaScript Deobfuscation Introduction. Welcome to the JavaScript Deobfuscation module. Code deobfuscation is an important skill to learn if we want to be skilled in code analysis and reverse engineering. During red and blue team exercises, we often come across obfuscated code that wants to hide certain functionalities, like malware that utilizes obfuscated JavaScript code to retrieve its main payload. Without understanding what this code is doing, we may not know what exactly the code is doing, and hence may not be able to complete the red or blue team exercise. In this module, we start by learning the general structure of an HTML page, and then we'll locate JavaScript code within it. Once we do that, we will learn what obfuscation is, how it is done, and where it is used, and follow that by learning how to deobfuscate such code. Once the code is deobfuscated, we will attempt to understand its general usage to replicate its functionality and uncover what it does manually. The following topics will be discussed: locating JavaScript code, intro to code obfuscation, how to deobfuscate JavaScript code, how to decode encoded messages, basic code analysis, and sending basic HTTP requests. Source code. Most websites nowadays utilize JavaScript to perform their functions, while HTML is used to determine the website's main fields and parameters, and CSS is used to determine its design. JavaScript is used to perform any functions necessary to run the website. This happens in the background, and we only see the pretty font end of the website and interact with it. Even though all this source code is available at the client side, it is rendered by our browsers, so we do not often pay attention to the HTML source code. However, if we wanted to understand a certain page's client-side functionalities, we usually start by taking a look at the page's source code. This section will show how we can uncover the source code that contains all of this and understand its general use. HTML. We will start by starting the exercise below, open Firefox in our phone box, and visit the URL shown in the question. As we can see, the website says secret serial generator, without having any input fields or showing any clear functionality. So our next step is to peek at its source code. We can do that by pressing Ctrl U, which should open the source view of the website. As we can see, we can now view the HTML source code of the website. CSS. CSS code is either defined internally within the same HTML file between style elements, or defined externally in a separate .css file and referenced within the HTML code. In this case, we see that the CSS is internally defined, as seen in the code snippet below. If a page CSS style is externally defined, the external.css file is referred to with the link tag within the HTML head as follows. JavaScript. The same concept applies to JavaScript. It can be internally written between script elements or written into a separate .js file and referenced within the HTML code. We can see in our HTML source that the .js file is referenced externally. We can check out the script by clicking on secret.js, which should take us directly to the script. When we visit it, we see that the code is very complicated and cannot be comprehended. The reason behind this is code obfuscation. What is it? How is it done? Where is it used? So I've got my pwn box already set up, so I'll just start the target. Repeat what you learn in this section, and you should find a secret flag. What is it? So it wants us to visit the page, so we'll open it in our browser within pwn box. Once this loads here, secret serial generator. This page generates secret serials. So either we can right click and go there or hit Control U. Taking a look through the source code, this is our CSS, the styling, and there it is, our flag. Always read the source code. So we'll copy that and paste that in. Code obfuscation. First, let's see what happens. Okay, so like in the example, it's kind of long and obfuscated. Here we go. There's another flag there almost. The serial generator. Okay. So, code obfuscation. Before we start learning about deobfuscation, we must first learn about code obfuscation. Without understanding how code is obfuscated, we may not be able to successfully deobfuscate the code, especially if it was obfuscated using a custom obfuscator. What is obfuscation? Obfuscation is a technique used to make a script more difficult to read by humans, but allows it to function the same from a technical point of view, though performance may be slower. This is usually achieved automatically by using an obfuscation tool, which takes code as an input and attempts to rewrite the code in a way that is much more difficult to read, depending on its design. For example, code obfuscators often turn the code into a dictionary of all the words and symbols used within the code, and then attempt to rebuild the original code during execution by referring to each word and symbol from the dictionary. The following is an example of a simple JavaScript code being obfuscated. So codes written in many languages are published and executed without being compiled in interpreted languages such as Python, PHP, and JavaScript. While Python and PHP usually reside on the server side and hence are hidden from end users, JavaScript is usually used within the browsers at the client side, and the code is sent to the user and executed in clear text. This is why obfuscation is very often used with JavaScript. Use cases. There are many reasons why developers may consider obfuscating their code. One common reason is to hide the original code and its functions to prevent it from being reused or copied without the developer's permission, making it more difficult to reverse engineer the code's original functionality. Another reason is to provide a security layer when dealing with authentication or encryption to prevent attacks on vulnerabilities that may be found within the code. It must be noted that doing authentication or encryption on the client side is not recommended, as code is more prone to attacks this way. The most common usage of obfuscation, however, is for malicious actions. It is common for attackers and malicious actors to obfuscate their malicious scripts to prevent intrusion detection and prevention systems from detecting their scripts. In the next section, we will learn how to obfuscate a simple JavaScript code and attempt running it before and after obfuscation to note any differences. Basic obfuscation. Code obfuscation is usually not done manually, as there are many tools for various languages that do automated code obfuscation. Many online tools can be found to do so, though many malicious actors and professional developers develop their own obfuscation tool to make it more difficult to deobfuscate. Running JavaScript code. Let us take the following line of code as an example and attempt to obfuscate it. So console.log, hack the box JavaScript deobfuscation module. First, let's test running this code in clear text to see it work in action. We can go to JS console, paste the code, and hit enter and see its output. We see that this line of code prints hack the box JavaScript deobfuscation module, which is done using the console.log function. Minifying JavaScript code. A common way of reducing the readability of a snippet of JavaScript code while keeping it fully functional is JavaScript minification. Code minification means having the entire code in a single, often very long, line. Code minification is more useful for longer code, as if our code only consisted of a single line, it would not look much different when minified. Many tools can help us minify JavaScript code, like JavaScript minifier. We can simply copy our code and click minify, and we get the minified output on the right. Once again, we can copy the minified code to JS console and run it, and we see that it runs as expected. Usually minified JavaScript code is saved with the extension .min.js. Note, code minification is not exclusive to JavaScript and can be applied to many other languages, as can be seen on JavaScript minifier. Packing JavaScript code. Now let us obfuscate our line of code to make it more obscure and difficult to read. First, we'll try beautiful tools to obfuscate our code. We see that our code became much more obfuscated and difficult to read. We can copy this code to the jsconsole.com to verify that it still does its main function. We see that we get the same output. Note, the above type of obfuscation is known as packing, which is usually recognizable from the 6 function arguments used in the initial function packed. A packer obfuscation tool usually attempts to convert all words and symbols of the code into a list or a dictionary, and then refer to them using the packed function to rebuild the original code during execution. The packed can be different from one packer to another. However, it usually contains a certain order in which the words and symbols of the original code were packed to know how to order them during execution. While a packer does a great job reducing the code's readability, we can still see its main strings written in clear text, which may reveal some of its functionality. This is why we may want to look for better ways to obfuscate our code. Advanced obfuscation. So far, we've been able to make our code obfuscated and more difficult to read. Pardon me. However, the code still contains strings and clear text, which may reveal its original functionality. In this section, we'll try a couple of tools that should completely obfuscate the code and hide any remnants of its original functionality. Obfuscator. Let's visit obfuscator.io. Before we click obfuscate, we will change string array encoding to base 64 as seen below. Now we can copy our code and click obfuscate. We get the following code. This code is obviously more obfuscated and we can't see any remnants of our original code. We can now try running it in jsconsole.com to verify that it still performs its original function. Try playing with the obfuscation settings in obfuscator.io to generate even more obfuscated code, and try rerunning it in jsconsole.com to verify it still performs its original function. More obfuscation. Now we should have a clear idea of how code obfuscation works. There are still many variations of code obfuscation tools, each of which obfuscates the code differently. Take the following JavaScript code for example. We can still run this code and it would still perform its original function. The above code was snipped as the full code is too long, but the full code should successfully run. We can try obfuscating code using the same tool in JSF and then rerunning it. We will notice that the code may take some time to run, which shows how code obfuscation could affect the performance, as previously mentioned. There are many other JavaScript obfuscators, like JJ-encode or AA-encode. However, such obfuscators usually make code execution or compilation very slow, so it is not recommended to be used unless for an obvious reason, like bypassing web filters or restrictions. Deobfuscation. Now that we understand how code obfuscation works, let's start our learning towards deobfuscation. Just as there are tools to obfuscate code automatically, there are tools to beautify and deobfuscate the code automatically. Beautify. We can see that the current code we have is all written in a single line. This is known as minified JavaScript code. In order to properly format the code, we need to beautify our code. The most basic method for doing so is through our browser DevTools. For example, if we were using Firefox, we can open the browser debugger with Ctrl-Shift-Z and then click on our script secret.javascript. This will show the script in its original formatting. But when we click on the brackets button at the bottom, which will print pretty the script into its proper JavaScript formatting. Furthermore, we can utilize many online tools or code editor plugins like Prettier or Beautifier. Let's copy the JavaScript, the secret.js script. So we can see that both websites do a good job in formatting the code. So these are the two, prettier.io and beautifier.io. They just pasted it in, and however, the code is still not very easy to read. This is because the code we are dealing with was not only minified, but obfuscated as well. So simply formatting or beautifying the code will not be enough. For that, we will require tools to deobfuscate the code. Deobfuscate. We can find many good online tools to deobfuscate JavaScript code and turn it into something we can understand. One good tool is JSNice. Let's try copying our above obfuscated code and run it in JSNice by clicking the Nicify JavaScript button. we should click on the Options button next to the Nicify JavaScript button and deselect Infer Types to reduce cluttering the code with comments. Tip: ensure you do not leave any empty lines before the script, as it may affect the deobfuscation process and give inaccurate results. We can see that this tool does a much better job in deobfuscating the JavaScript code and gave us an output we can understand. As previously mentioned, the above used method of obfuscating is packing. Another way of unpacking such code is to find the return value at the end and use console.log to print it instead of executing it. Reverse engineering. Though these tools are doing a good job so far in clearing up the code into something we can understand, once the code becomes more obfuscated and encoded, it would be much more difficult for automated tools to clean it up. This is especially true if the code was obfuscated using a custom obfuscation tool. We would need to manually reverse engineer the code to understand how it was obfuscated and its functionality for such cases. If you're interested in knowing more about advanced JavaScript deobfuscation and reverse engineering, you can check out the Secure Coding 101 module, which should thoroughly cover this topic. So we still have the same target. Using what you learned in this section, try to deobfuscate secret.js in order to get the content of the flag. What is the flag? So we kind of saw it partially before, but let's bring up our DevTools, if I can. And then, remember it was in the secret. So we click on the secret, right? Elements. Let's just bring this up. Open file in debugger. Let's take a look. Okay, so it's in debugger, and then it said to click this button down here, the brackets, for the pretty view, and it is still obfuscated. So we'll copy it all and go to our tool, which was JS is nice. What was that? jsnice.org. Oops. So I'm going to put it here, make sure that it's all empty, paste that. It said a couple more things, so we should click the options button and deselect infer types. So we want to deselect infer types, and then we should be good to go. So nicify, and there we go. So we kind of had a glimpse of it earlier. I am the serial generator. Okay, so we can paste that in. Carrying on with code analysis. Now that we have deobfuscated the code, we can start going through it. We see that the secret.js file contains only one function: generate serial. HTTP requests. Let us look at each line of the generate serial function. Code variables. The function starts by defining a variable xhr, which creates an object of XML HTTP requests. As we may not know exactly what XML HTTP request does in JavaScript, let us Google XML HTTP request to see what it is used for. After we read about it, we see that it is a JavaScript function that handles web requests. The second variable defined is the URL variable, which contains a URL to /serial.php, which should be on the same domain, as no domain was specified. Code functions. Next, we see that XHR is open. Next, we see that xhr.open is used with post and URL. We can Google this function once again and see that it opens the HTTP request defined get or post to the URL, and then the next line, xhr.send, would send the request. So all generate serial is doing is simply sending a post request to /serial.php without including any post data or retrieving anything at all. The developers may have implemented this function whenever they need to generate a serial, like when clicking on a certain generate serial button, for example. However, since we did not see any similar HTML elements that generate serials, the developers must not have used this function yet or kept it for future use. With the use of code deobfuscation and code analysis, we were able to uncover this function. We can now attempt to replicate its function to see if it is handled on the server side when sending a POST request. If the function is enabled and handled on the server side, we may uncover an unreleased functionality, which usually tends to have bugs and vulnerabilities within them. HTTP requests. In the previous section, we found out that the secret.js main function is sending an empty post request to /serial.php. In this section, we will attempt to do the same thing using curl to send a post request to /serial.php. To learn more about curl and web requests, you can check out the web requests module. Curl. Curl is a powerful command line tool used in Linux distributions, Mac OS, and even the latest Windows PowerShell versions. We can request any website by simply providing its URL, and we would get it in text format as follows. This is the same HTML we went through when we checked the source code in the first section. Post request. To send a post request, we should add the $X post flag to our command, and it should send a post request. Tip: we add the -s flag to reduce cluttering the response with any unnecessary data. However, post request usually contains post data. To send data, we can use the -d param1 equals sample flag and include our data for each parameter as follows. Now that we know how to use curl and to send basic post requests, in the next section we will utilize this to replicate what server.js is doing to understand its purpose better. Pardon me. Try applying what you learned in this section by sending a post request to /serial.php. What is the response you get? So we're going to do that. So we're just going to curl -x with a sample parameter. curl HTTP paste post, and then -d, we're going to just say param1 equals hey, and see what happens. And here we go. Always read the source. That was from before, so let's just see. Oh yeah, /serial.php. And this time we get a response. So we'll copy this and paste this in. And continue. Decoding. After doing the exercise in the previous section, we got a strange block of text that seemed to be encoded. This is another important aspect of obfuscation that we refer to in more obfuscation in the advanced obfuscation section. Many techniques can further obfuscate the code and make it less readable by humans and less detectable by systems. For that reason, you will very often find obfuscated code containing encoded text blocks that get decoded upon execution. We will cover 3 of the most commonly used text encoding methods: base64, hex, and rot13. base64. Base64 encoding is usually used to reduce the use of special characters, as any characters encoded in base64 would be represented in alphanumerical characters, in addition to the plus sign and a backslash only. Regardless of the input, even if it is in binary format, the resulting base64 encoded string would only use them. Spotting base64. Base64 encoded strings are easily spotted since they only contain alphanumerical characters. However, the most distinctive feature of base64 is its padding using the equal sign characters. The length of base64 encoded strings has to be in a multiple of 4. If the resulting output is only 3 characters long, for example, an extra equal sign is added as padding, and so on. So base64 encode. To encode any text into base64 in Linux, we can echo it and pipe it with the pipe to base64. So echo hackthebox.eu pipe base64. Base64 decode. If we want to decode any base64 encoded string, we can use the base64-d as follows. So the same thing, we're echoing our string, piping it with base64-d. Hex. Another common encoding method is hex encoding, which encodes each character into its hex order in the ASCII table. For example, A is 61 in hex, B is 62, C is 63, and so on. You can find the full ASCII table in Linux using the man ASCII command. Spotting hex. Any string encoded in hex would be comprised of hex characters only, which are 16 characters only, 0 through 9 and A through F. That makes spotting hex encoding strings just as easy as spotting base64 encoded strings. Hex encoding. To encode any string into hex in Linux, we can use the xxd-p command. Hex decode. To decode a hex encoded string, we can use the xxd-p-r command. And Caesar/rot13. Another common and very old encoding technique is a Caesar cipher, which shifts each letter by a fixed number. For example, shifting by one character makes A become B, and B becomes C, and so on. Many variations of the Caesar cipher use a different number of shifts, the most common of which is Rot 13, which shifts each character 13 times forward. Spotting Caesar or Rot 13. Even though this encoding method makes any text look random, it is still possible to spot it because each character is mapped to a specific character. For example, Rot 13, HTB www becomes UGGC JJJ, which still holds some resemblances and may become recognized as such. Rot 13 encode. There isn't a specific command in Linux to do Rot 13 encoding. However, it is fairly easy to create our own command to do the character shifting. So we can echo hackthebox.eu tr a through z, capital Z, lowercase a through z, and then our changes there, n through z, a through m, n through z, a through m. So decode. We can use the same previous command to decode Rot 13 as well. So it's the exact same command, but we're using the encoded string. Another option to encode/decode Rot 13 would be using an online tool like Rot 13. I agree. Other types of encoding. There are hundreds of other encoding methods we can find online. Even though these are the most common, sometimes we will come across other encoding methods which may require some experience to identify and decode. If you face any similar types of encoding, first try to determine the type of encoding and then look for online tools to decode it. Pardon me. Some tools can help us automatically determine the type of encoding, like Cipher Identify. Try the encoded strings above with Cipher Identify to see if it can correctly identify the encoding method. Other than encoding, many obfuscation tools utilize encryption, which is encoding a string using a key, which may make the obfuscated code very difficult to reverse engineer and deobfuscate, especially if the decryption key is not stored within the script itself. Grab some water here. And our question, using what you learned in this section, determine the type of encoding used in the string you got at previous exercise and decode it. You got at the previous exercise and decode it. To get the flag, you can send a post request to serial.php and set the data as serial equals your decoded output. So basically we just need to grab it. We have it here. Copy that. We can use our tool, Cipher Identify. We'll just open that in Edge. Paste that in. Analyze text. It's base 64. And then what do we do next? We want to decipher that. So now that we know that it's base 64, let's use it. So we echo our string pipe base 64-d. So let's practice that. So echo paste pipe base 64-d. And this is a secret message is our answer. So we'll copy that, and we're going to do the same thing as before. We're posting our data. We're saying that the serial equals this. And just to confirm, that's what it wanted. Serial equals that. and we'll hop back and send that through. I think my quotes are off. A secret message. Try it again. Okay, and there's our flag. Just another random serial. So we'll copy that and paste that in. And last but not least, our skills assessment. During our penetration test, we came across a web server that contains JavaScript and APIs. We need to determine their functionality to understand how it can negatively affect our customer. And we've got a number of questions here. I'll go ahead and read through them first and spawn the target. Number 1, try to study the HTML code of the web page and identify used JavaScript code within it. What is the name of the JavaScript file being used? Once you find the JavaScript code, try to run it and to see if it does any interesting functions. Do you get something in return? As you may have noticed, the JavaScript code is obfuscated. Try applying the skills you learned in this module to deobfuscate the code and retrieve the flag variable. Try to analyze the deobfuscated JavaScript code and understand its main functionality. Once you do, try to replicate what it's doing to get a secret key. What is the key? And once you have the secret key, try to decide its encoding method and decode it. Then send a post request to the same previous page with the decoded key as key equals decoded key. And what is the flag you get there? So we'll start by visiting the page and checking out the source code. So API keys control panel, and we'll view the page source. We're looking through, there's our CSS, and we get this. So last time we had a flag on this page, I'm not seeing one this time. We'll try to view the source of this. This was also packed. So let's open that in a new tab and just jump back to our question. Once you find it, try to study the HTML code and identify. So the name of the JavaScript file being used first is api.min.js. And remember, min was minified, so we'll take a look at that. api.min.js. Once you find the JavaScript code, try to run it to see if it does any interesting functions. So we'll try to run it. So that was with our debugger. Console inspector. Spread this wider here. API keys. Where is this? Can I just search it? Yes. api.min.js. Okay. There it is. So let's send that to what did we do last time? View source. Because we're not trying to view the source. Trying to do it here. So the same thing. There it is. Clicking on this. That was in debugger. There's our JavaScript. Try to run it. Let's just get the pretty print source. And we'll just copy it for now so that we have it. So console, I think this was from earlier. No? This might be our key. Let's take a look. Okay, so in the console we can run that particular script, and that's what we return. Okay, so we have it. Let's move on to our third one. As you may have noticed, the JavaScript code is obfuscated. Try applying the skills you learn in this module to deobfuscate it and retrieve the variable flag. So that was the, what was that one? JS console, I believe. We might have that open in over here. Serial generator. No, that was earlier. JS console. Let's see. jsnice.org. Okay, perfect. So we copy this and paste it. Oops. So we'll just copy this since that's what we need. Paste that. No, wait. We want the nice version, I believe. Where were we? Okay, here we go. So we'll copy that and paste that here. No spaces. Make sure we uncheck that and nicify. And so this looks like our next part. We'll just copy that. And go back to our console if possible. See what happens if we just paste this in. I don't think it works. Try it again. Rip enum is key. Console, paste. Okay. Please select allow pasting button below to allow pasting. Okay, where is that? Allow pasting button. I don't see an allow pasting button. Okay. So we'll Google it. Where is allowed pasting button? Debug tools. Firefox. Open console and type allow pasting and hit enter. Okay, that was simple enough. Please type. Oh, that's what it says, of course. Allow pasting. Enter. There we go. Okay. That wasn't that our thing from before? JavaScript enumeration is key. Never run obfuscate code. Obfuscated code. Okay, hold up. So, from our answers, JavaScript enumeration is key. Try applying the skills and retrieve the flag variable. So let's take a look. The flag variable. Okay, so it wants the entire variable of the flag. Entire flag variable. Never run obfuscated code. Is that, let's try it with the quotes, both quotes. Semicolon. Let's just try it together. Okay, that's not what it wanted. So try to analyze the deobfuscated code JavaScript and understand its main functionality. So, oh wait, I think I deleted that. Okay, so that's what it wanted. We had to just grab it manually there. Try to analyze the deobfuscated JavaScript code and understand its main functionality. Once you do, try to replicate what it's doing to get a secret key. What is the secret key? So we have to take a look at the code and see what it's doing. So we'll jump back to the other page here. Okay, so it's sending a post request to keys.php. So that's what we're going to do, just like before. So instead of this IP address, we need to grab our new one, and we're going to keys.php, and we're just trying an example parameter. So just say param1 equals test, and we'll grab the IP address and port number, jump back, looks good. Thought I cleared this out, but we'll do it again. Paste that in. Keys.php. Post param test1. Here we go. And we get, once again, just like before, this here. So it's asking, what is the key? This is the key. Alright. And we want to identify the cipher. So we'll paste this here. This is the cipher identifier. Analyze text. This time it's hexadecimal code. So we should take a look and see how we did that before. I think it was XXD. Let's see. XXD-P. So we're going to echo the string pipe XXD-P-R. So echo our string pipe XXD-P-R. And this is our flag. API pen testing is fun. And jumping back to the skills assessment page. And you know what? That was fun. Oh, API pen testing is fun. What is the flag? Oh, yes. We got to post the decoded key first. So then we're going to go back. It's asking for key equals paste. So we're not done quite yet. There we go. So ready to hack my way into Hack the Box. Great stuff. And we're done. So, in summary, congratulations on reaching the end of the JavaScript deobfuscation module. We hope you can now recognize obfuscated scripts and deobfuscate them, decode their output, and replicate their functions. The following is a summary of what we learned. First, we uncovered the HTML source code of the web page and located the JavaScript code. Then we learned about various ways to obfuscate JavaScript code. After that, we learned how to beautify and deobfuscate minified and obfuscated JavaScript code. Next, we went through the deobfuscated code and analyzed its main function. We then learned about HTTP requests and were able to replicate the main function of the obfuscated JavaScript code. Finally, we learned about various methods to encode and decode strings. And finished. So that has been the JavaScript deobfuscation module. And our next module, we will be continuing. We're at 19%. So far, with our next open section, we're going to be hopping into our next open module, which is SQL Injection Fundamentals. So once again, my name is Sleeper, and that's a wrap. Until next time.